Welcome, friends, to the one with the Unit 11 review. We're going to start things a little backwards than we normally do. We're going to start with the application problem. So, first application problem, you have a chord that's 30 centimeters, and it's 7 centimeters from the center of a circle. By the way, all these problems coming off of the review. I always recommend drawing a picture. So this distance here is 7. The whole distance is 30, so that means that each half is 15, because we know that this is bisected there. Question is, calculate the area of the circle to the nearest tenth. Well, we know that area equals pi r squared. Okay, Mr. Brust taught us that. And so we need the radius. Here we don't have a radius yet. That's 15 is not a radius because it's not coming from the center. So what we're going to do is we're going to draw a radius in right here conveniently because we know this is a right angle, and now we can do a squared, b squared, c squared. That's going to give us the radius. Then you can plug it in, square it times pi. That'll give you the area. So that's all you have for that one. Number 2, we have Sully riding an airplane. All right, you're going to see that the Pythagorean theorem comes up so much here. We have the center of a circle. Sully's up here. He's 5. Let's measure this. He is 5.5 miles above the Earth. Okay, that's right there, that distance. And we got to remember the Earth's diameter is approximately 7920. That means that the radius is about, what, 3960? All right, so we can draw in a radius here. I'm going to draw, look, Sully's going to look to the corner of the Earth. Remember, this is not to scale, and we're going to bring that in here. So this distance right here is going to be your 3960. All right, now that's also the same distance that you have here because that's a different radius, but they're both radii. All right, so both of those are 3960. If I look at the entire length of this line segment here, let's mark it in red, then it's going to be 3960 plus 5.5, or the entire length. Let's do this. Let's draw the triangle out here. So we have a right angle right here, and this side's going to be 3965.5, and I get that from adding these two pieces together. All right, well, that's the hypotenuse, and we have this side is 3960. We can put an x right there. Now it's a squared, b squared, c squared. What do they want us to find? How far is the furthest point that Sully can see on the Earth? That's this distance right here. That's how far furthest point he can see on the Earth is. So you should get an answer. Make sure you check it for reasonableness. I'm not going to figure it out, but that's Pythagorean theorem again. Number 3, diameter of a circle is 50 centimeters. So let's draw the circle. Diameter goes through the middle. All right, so is parallel, let's see, and a chord that's parallel to that is 32 centimeters. Look at that. Someone hit my circle in. Got to get your circle on here. All right, so how are we going to do this? Well, I'm going to use a different color because we know that this diameter, what do we know? If we draw a line straight to the chord, then we know that it's perpendicular and it bisects. So we know that this half is 16, this half is 16. I can also figure out that the radius is 25, okay, because it's half of 50, so we got 25 and 25. So if I draw a radius to here, that would also be 25. They want to know to the nearest tenth, what is the distance to the chord from the center of the circle? That's this distance right here. So look what we have again, right triangle. Let's draw the triangle over here. We have, ta-da, 16, x, 25, a squared, b squared, c squared. You can find the answer to that one, and you're good to go. Make sure you go to the nearest tenth. Last application problem. Look, these application problems are all Pythagorean theorem. How fun is that? Brust is chillaxing up in a hot air balloon. He estimates the viewing angle of the Earth formed by two tangents is 120 degrees. So I'm going to draw, here we go, here's the Earth, and Brust is up here, and he's looking this way. We'll make our circle a little bigger so they intersect. And he says the angle between them is 120 degrees. Okay, so here's the center. He estimates the viewing angle. What do we got to find? Find the measure of the arc of the Earth's surface viewable from the balloon. All right, so this is actually kind of easy because if you draw the radius here and you draw the radius here, we know that this is a right angle. I'm also going to draw a line straight down the middle. All right, so we have our right triangle again. And if this entire angle is viewable is 120 degrees, then I know that this half right here is 60. And if this is 90, because remember a tangent and a radius are perpendicular, then we know that the central angle here is 30. And they're congruent triangles on both sides, so this would be 60 and that would also be 30. So the measure of the arc, the Earth's surface viewable from the balloon, would have to be the measure of these two central angles put together, so that would be 60 degrees. I just gave you the answer to that one. Okay, in part C, if the radius of the Earth is about 3960, calculate the distance from the Earth's surface to the balloon. Alright, so we're looking specifically, this is C, we're looking for this distance right here. So we know that this is 3960. We know that this piece here is also 3960, but let's call this whole distance y. Okay, and what else do we know? Well, we have a 60-degree angle, so what we can do is use sine, cosine, tangent, one of those trig functions, or you can have a 30, 60, 90 triangle. I'm going to draw just the triangle out here. So this was 60, this is 90. We know this is 3960. That's across from 60. So you're going to have to divide by radical 3, multiply by 2. This is our 30, 60, 90 triangle here. And you can figure that out. And then once you have that, that's the entire hypotenuse. You can subtract 3960 because you know that's this piece right here. And that'll leave you with the distance from the Earth's surface to the balloon. There you go. It's all Pythagorean theorem for the application problems. Now let's look at some regular basic skill problems. What do you have to review for this test? Well, the first thing you have to review is that the measure of an angle inscribed is equal to half the measure of the arc, or the arc is twice the angle. Alright, so if the arc's twice the angle, this is 106. We're looking at what? 212 for the measure of RST. Alright, so that's the measure of RST. Let's see, we label our stuff out. This would be half, so we get 75 there. Easy enough. How about 3? We have the same thing going on as before. This is too easy. That's equal to 12 because they bisect. We're done with that one. For this one here, we have a squared plus b squared equals c squared. That's how you do that one there. I'm just going to tell you how to set these up. Alright, so for 7 and 8, what do we have? We have a secant and a tangent. Remember that this angle is half the measure of this intercepted arc right there. So if we take 360 and we subtract 280, we're going to get a measurement of 80. So this angle here has got to be 40 because it's half of that. Alright, so we just say that 11x minus 4 is half of 80. Or you could just write 40 if you want to. Then you can solve that and you're good to go. Okay, this angle out here, we have a tangent and we have a secant. So it's half the difference, remember. So 50 equals half the difference. You got to put the larger angle first, and you got to subtract. You got to use parentheses the smaller arc right there. I said angle before. It's actually arc. And then you go through. This is algebra. Distribute the negative and then multiply by a half. However you're going to solve that, use your algebra. You're good to go. Okay, so this is the same way as that. I'm just going to set it up for you. 50 is going to equal 1/2 of, we have 35x plus 5 minus, you got to use parentheses, 5 plus 10x. And then you have to work that algebra out and you're good to go. Okay, how about 10? We start to deal with segments here. So remember that the distance, it's the entire secant here. So it's the external part times the entire secant is going to equal the tangent squared. Alright, so on this one you got to work that out. You know, distributive property, 8x plus 64 equals 144, so on and so forth. That's how you do that one. Alright, number 12, 70 degrees is going to equal, what's the theorem here? Well, it's half the difference between the major arc and the minor arc. So how do we figure out what this arc is? Well, that arc right there is, we'll figure it out over here, 360 minus 23. I'm going to write this differently. I'm going to write it out. 360 minus 23x minus 3. But you got to put this in parentheses because you're subtracting that entire arc. So when you subtract it, you got to subtract the entire thing, including the negative. So I'm just going to simplify this. 360 minus 23x plus 3. All right, you good with that? Because I distributed that negative there. So we get 360 plus 3 is 363. But we have a negative 23x. Put a plus in the middle. This is what goes right there on this arc. So then your next equation is 70. I already have it up here. Get rid of that. Equals 1/2 of, and here's where it gets a little bit messy, 23x minus 3 minus, and then you got to use your parentheses, negative 23x plus 363. what am I, 363. Then we're good to go there. Okay? Distribute that negative. I know I ran out of room, so it looks a little sloppy, but that's basically going to get you in the right direction. This is like the other one that we got. Let's clear out what we have. We have 6 times. We got to put the whole sec in here. So x plus 6. That's going to equal 7 times 5 plus 7. Alright, so what do we got? 6x plus 36 equals 35 plus... Why did I distribute that? Why don't I just do 7 times 12? Let's do that. Yeah. 7 times 12, what's that, 84? I'm taking a guess there. Is that 84? Yeah, I think it is. And then you go through and you can solve that one. I don't need to solve that. You can solve that one. Number 13, when we have 2 chords that bisect, then remember the product of the segments are equal to each other. So we're going to get 4 times 8x plus 1 is going to equal 6 times 6. I like to write it out here so you see what's going on. So 32x plus 4 equal to 36. Subtract, x will equal 1 in that one. Hey, I just gave you an answer. Same thing for this. Just be careful. Look at both of them. You got to find what they're asking you to find. So in 13, they ask you to find df. So you take your x equals to 1, plug it in here into 8x plus 1. You're going to get 9, 4, 13. There you go. So df here is going to equal 13. On the right, what do we get? 6 times x plus 6 is going to equal 5 times 5 plus 7. So this is 5 times 12, which is 60. We get 6 times x plus 6. I'm going to divide both sides by 6. Ooh, what's that going to do? That's going to give you this, and x is going to equal 4. Find JL. JL, if this is 4, JL is going to equal 10. Hey, we're going quickly through all these because I don't want to make a 50-minute video. Next question, same as the last one. 10 times 3x minus 6 is going to equal, so what do we got? 8 times 15. So 8 times 15 is what? 120? Taking a guess there. It's an educated guess. I think I'm right. Equals 160, so on and so forth. Solve it. You're good to go. Okay, number 16 here. What do we have? This is the only time you have a half the sum type of problem. So the central angle here is equal to half the sum of those 2 arcs. So we need to add those 2 arcs together. So 61x plus 3 plus 19x minus 3. Alright, so we need to add all these together. So the 3 and the negative 3 cancel. We're going to get 39x plus 3 equals half of, if I add those x's together, you get 80x. So 39x plus 3 is going to equal 40x. Subtract, you're going to get 3 equals x. Hey, and then they want UTV. UTV. So plug a 3 into here. So you get 117 plus 3, which is 120. So you're going to get that angle to equal 120 when you plug it in. Easy enough, huh? It's easy stuff. What do we got? 2 more. Find, what do we have here? This is easy. So the inscribed angle is equal to half the intercepted arc. So the arc across, I always like to draw in the angle, and then this arc right here, the angle is equal to half of the measure of the arc. Alright, so if you distribute here, 7x minus 4 is going to equal 6x plus 8. We have x equals 12 for that one. Don't forget to plug it back in. And oh, this one's so easy. Tangent. If you have one external point and 2 tangents, they have to be equal to each other. The 2 tangent lengths are equal. So, hey, done with that one. 2x equals 10. X equals 5. Don't forget to plug it in. Nope, we don't have to solve for x. And that is it. We have everything figured out there for the review. I know I went pretty quickly, but this is a 15-minute video as it is probably. That's it for geometry for me. Hey, this is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. So